Hello friends, so you see the limit gauges. What is the use of limit gauges? How we can design these limit gauges? What is Taylor's principle for limit gauges? And how we can implement it. So many times you might have seen that in test cricket match that umpires are carrying two types of gauges with them. So this test cricket match ball is used for a 90 overs. But in between, if the ball size gets changed, then how to check that whether it is in permissible limits or not? Because there we cannot carry vernier caliper, micrometer, checking the roundness by using the roundness testing gauge. So it is very difficult. But still we have to find out that whether it is in a acceptable limits or not. So what they carry the two types of disc. One is called as a go gauge. So the ball should go from that gauge. And the second one is a no go gauge. So ball should not go from that. So if you satisfy both these conditions, then we can say that the ball is in a playing condition. And it is very easy now to check that whether it is in a condition to play without checking its original dimensions, without checking its exact dimension. And many times we'll have the similar type of situation that we don't want to check exact dimensions of the component. Just we want to make a decision that whether the part is accepted or whether the part is rejected. So on what basis we can make this decision that whether the part is accepted or rejected? Because if you want to check each and every component and measure it and then do the analysis for it, whatever the time required for manufacturing, more than that time will be required for the inspection. So if you want to reduce that time, we should use these limit gauges. So limit gauges will just give you the idea that whether the part is within the permissible limits or not. And generally we are using the two types of gauges for it, like a go gauge and no go gauge. So for example, what are the purposes of these limit gauges? So just to check that whether the component is within these two limits, that is the upper limit and lower limit of the component. So if the dimensions are outside this limit, we are going to reject the component, otherwise we are going to use it. Any measuring instrument, these dimensions, the process will take a lot of time for measurement, so we are using these limit gauges. But the main limitation of this limit gauge is that we don't know the exact size. So many times we cannot do the analysis of the process. So basically there are three types of limit gauges are there: plug gauge, ring gauge and snap gauge. So plug gauge are used to check hole sizes. So we are having a plug and there are two sides of the plug, that is a go side and no go side. You can see over here go and no go. Sometimes we can use a progressive type of plug gauge where the go and no go on the same side. So what condition it should satisfy? The go side should go inside the hole, whereas no go side should not go inside the hole. So this is the go side should go inside, no go side should not go inside. It means that the hole dimension is within the limits that we want. Sometimes we are making the plate type of plug gauge also. There are some benefits of this. We'll discuss it in the next slide. So this plug gauge will decide that whether the hole is of a required quality or not. So if you want to check the taper hole, then in that case we are using a taper plug gauge. So in taper plug gauge we don't have a go and no go, because the go and no go are marked on the same taper plug gauge by the two lines. So one line is a go line, so it should be inside this taper hole, and the no go line should be outside of the taper hole. So if this condition is satisfied, then we are going to accept that taper hole. Otherwise, if this no go side goes inside, we are going to reject it. Or go side is outside, then also we are going to reject it. And if you want to check the shaft dimensions, then we are using a ring gauges. So there are separate ring gauges are required: go ring gauge and no go ring gauge. So if you put that go ring gauge on the shaft, then we'll decide that whether the shaft dimensions are correct or not on the upper side, whereas the no go ring gauge will decide on the lower side of it. These similar principles can be used for checking of the threads. So instead of measuring the thread parameters, we can just use the go and no go of thread gauges, and we can check that whether the threads which you have manufactured are within the limits or not. Or we can use the thread ring gauges to check the dimensions of the internal and external threads. The snap gauge is the third type of gauges which are used. These snap gauges are used to check the external dimensions again. but these are very handy. So there is one side which is a go side, second side is a no go side. Go side should go go from the component, no go side should not go. But here also, if you see, if you use this snap gauge, then I have to check the go side, then I have to turn it by 180 degree, and then I have to check the no go side. And again, this turning by 180 degree will take some time. So we are using progressive type of a snap gauge where the go and no go are on the same side. So no need to turn it 180 degree. But what difference it will make just by turning? So if that turning is taking some 3 seconds, and if you are checking 1000 components, the 1000 components will take 3000 seconds. So that will be a considerable amount of time. And as we have seen that the gauges are designed for one type of a dimension only. So we require a huge number of gauges if you want to check large number of components. So instead of that, we can go for the adjustable type of a snap gauge where we can adjust the dimensions within some limits. So for example, we can use the slip gauges and we can set these dimensions for the go side and no go side, and we can use for the certain range of components. So no need to use different types of gauges for each component. Filler gauge is also a type of a limit gauge which will decide the gap between the assembly, gap between the spark plug. So this is also very interesting, very easy to measure the spark plug gap or a small gap between the assembly. So these are the applications of the filler gauge. So by using this filler gauge, we can get the certain type of a assembly and we can put it in the gap, and we can find out the dimensions which are engraved on that filler gauges. Directly we can measure it by adding them or subtracting them. So these are the applications that we can use it for the piston ring gap or piston ring clearance or connecting rod side clearance. We can use this. To check the fillet radius or the corner radius, we can use the radius gauge also. Again, a non-precision measuring instrument, but we can very easily, very quickly we can measure these dimensions. Not to the accuracy level that we want, but we can make a decision that whether the part is accepted or rejected. Or a thread pitch gauge where we can measure the pitch of the thread by using this thread pitch gauges. So these are the various types of limit gauges which can be used in the industry, that is a adjustable snap gauge, ring gauge, plug gauge, adjustable thread gauge, plug gauge, cylindrical pin gauge. So all these types of limit gauges are used in the industry. So advantages and limitations of the gauges. So these advantages is the measurement is very easy, very quick, no need of a skilled labor, so anybody can use it, and it is economical also because the time required is very less. But it is having some limitations also because we are not getting the actual size. We don't know whether what is happening in the manufacturing process, why we are not getting the correct dimensions. Also, it is possible that we will get a wear and expansion and the collapse of the gauges that we are using. So after a certain use of these gauges, we have to recheck them and we have to throw them if it is not in the given size. Large number of gauges are required because each dimension is required the different gauge. Instead of that, we can go for the adjustable snap gauge and ring gauge. It cannot handle the finer quality jobs because the dimensions accuracy is limited. And frequent checking is required because the wear will take place and we have to check that whether the gauges itself is having the required accuracy or not. Now these gauges are designed based on one principle which is called as the Taylor's principle of gauge design. And this Taylor's principle of gauge design says that go gauge should check the maximum metal condition and should check as many dimensions as possible, whereas the no go gauge should check only one dimension and it should check minimum metal condition. Now what is the meaning of this? Even though it is a three-line principle, but it is very important, very interesting, and we can explain these 3 lines in a more detailed way like this. So maximum metal condition means the maximum metal condition in hole is the lower limit and maximum metal condition in the shaft is the upper limit. So go gauge should check the lower limit of the hole, and if you are using that go gauge in case of a shaft, you should check the upper limit, whereas the no go gauge should check the minimum limit, minimum metal condition. So it should be maximum limit of a hole or minimum limit of the shaft. So here you can see the go gauge is checking the maximum metal condition in a hole, that is the lower limit. No go gauge is checking the minimum metal condition, so it is checking the upper limit. So in case of a shaft, it is go gauge is checking the maximum metal condition, that is the upper limit, and no go gauge is checking the minimum metal condition, that is the lower limit. But what is the meaning that it should check, GO gauge should check as many dimensions as possible? So for example, if you have this example, if you take this example, so if you make a GO gauge which is not of a full length, then if you put that GO gauge inside the hole, then you will get a conclusion that the hole is acceptable. But the problem is that hole is not having a straightness. So what we should do? We should make the GO gauge, which is a GO plug gauge, of a complete length, and it should not only check the diameter of the hole, it should check the straightness, it should check the flatness, circularity of the hole. So if you make a full length job or gauge, then it can check all these dimensions. But in case of a no-go gauge, as it is not going inside the hole or it is not going inside the shaft, so there is no need to check any other dimension. It will check only one dimension, that is the diameters of the hole and shaft. So this is again one more example they are given, that why we have to make the GO gauges of a full form. So for example, if you have this hole which is a lack of roundness or it is a lack of a circularity, if you not make it to a complete size or the full length, then the GO gauge can give the false result. So instead of that, we can make it of a full size, and such that we can make a correct conclusion based on this. So these are the some tolerances, how to allocate the tolerances on the limit gauges, because there are three types of gauges are there: workshop gauge, inspection gauge, and modern gauge or general purpose gauge. And we have to give tolerances to these gauges also. So there are some principles we have to use for giving these tolerances to the gauges. So in the next section, we'll see how these gauge tolerances are given, how the wear allowance to the gauges are given, and how these gauges are designed based on this Taylor principle, what we are seeing. Thank you.